Okay, let me try this again. So we're looking at a graph and we're going to be talking about what we call its end behaviors. End behaviors are really looking at this function as at this end towards the right, what's happening, how do we describe that, and then the other end on the left. And we describe it in two ways. We want to talk about how this function looks traveling towards positive x. So as our graph is going towards the right, what's happening? Well, as it's going towards the right, it is going up, and up is our positive infinity. So we can say as x approaches positive infinity, because that's positive, right? Positive infinity, f of x, the function approaches positive infinity, meaning it goes up. As I go right, the graph goes up. That's what that means. As I go left towards, which would be negative infinity, again this is my x-axis, so towards negative x, so negative infinity. So as it goes left, what's happening? Well, my function is going down to negative infinity. So I can say as we travel left on the x-axis, then our graph, our function, is approaching negative infinity. And there's different ways that our book words these. We could see it as the function of f of x approaches positive infinity as x approaches positive infinity. You might see it written out like this. You could see it written in words. The graph f of x approaches negative infinity as x approaches negative infinity, so that means we're going left and down. So as we work on this lesson, we are going to use this reference sheet here, and it is attached in Google Classroom, but this is going to help highlight the different end behaviors that can happen in a polynomial function. And we can describe the end behavior using this little cheat sheet by knowing the degree and the leading coefficient. If the degree of a polynomial is odd and the leading coefficient is positive, then what we expect to happen is as our graph approaches positive infinity, x approaches positive infinity, and as our graph approaches negative infinity, our x approaches negative infinity. So we can describe the graph by saying if our degree is odd, if the highest exponent is 1, 3, 5, 7, right, and our leading coefficient is positive, then we can say as I travel right, the function will be going up towards positive infinity, and as the function travels left, then the end behavior is going towards negative infinity. Okay, so I'll be referring to this paper a lot, so don't lose it. Okay? If our degree is odd, again, the highest exponent is 1, 3, 5, 7, 9, all those odd numbers, but our leading coefficient is a negative, so you will actually see the sign, the negative sign in front. Remember, positives are usually invisible as our leading numbers. Okay? But if we have a degree that's odd and a leading coefficient that's negative, we can expect the opposite to happen. So as I'm traveling right, so as x is going towards positive infinity, then my function, my f of x, is going towards negative infinity. It's going down. As I travel left towards negative infinity, as x goes left, my graph is going up towards positive infinity. If our degree is even and our leading coefficient is positive, we can expect that as we're traveling right, as x is approaching positive infinity, our function will also, our functions in behavior will also be going towards positive infinity. As I travel left on the x-axis towards negative infinity, our function will be traveling up towards positive infinity. If our degree is even and our leading coefficient is negative, we can expect the opposite to happen. So as x approaches, as we follow right and x approaches positive infinity, then our function will be going down towards negative infinity as our end behavior. As we travel left on the x-axis, our x values go towards negative infinity. Our graph will also travel towards negative infinity. Okay, so let's look at our first polynomial here, and we will be describing its end behavior. So go ahead and pause the video if you need to write that down. The only thing we need to know is the leading coefficient and the degree, and I will be using this little cheat sheet again here, so don't lose that during this whole lesson. Okay? Alright, so this polynomial is already in standard form. I can tell because I'm looking at those exponents and they are in descending order. 6, 5, 4, 3, 2, 1, that invisible 1, and then my constant. And so my leading coefficient is going to be in the very front, and what I need to know is, okay, it's 2. Well, it is a positive 2, right? So I need to know that it's positive. My degree is the highest exponent, which is 6, and 6 is an even number. So I need to know that it's positive and even. So if I look over here at my little cheat sheet, positive leading coefficient and an even degree. So even degree positive means that as I travel right on my x values to positive infinity, give it a minute to focus, then my graph will be going up towards positive infinity, and as I travel left, my end behavior is going up as well. So that is what I'm going to write down as my answer. So I can say, as my function travels towards positive infinity, as x approaches negative infinity, just left to right here, and then as f of x travels towards positive infinity, as x travels towards positive infinity. Forgive my infinity symbols, I am really bad at drawing them, so I just use 2 little circles. And that would be my description of my end behaviors. That would be my solution. Okay, our next example, it has our function, and I'm just going to write this down because this is the common mistake. Remember it to check, make sure it is in standard form before we start to explain the end behaviors, okay? So standard form, highest exponent to the least, 3, 1, they are in descending order, so let's go ahead and start identifying them. Again, don't lose our little cheat sheet here to help us as a reference. So my leading coefficient is -5, which means it's negative. And my degree is 3, which is odd. So I'm looking for an odd degree and a negative leading coefficient. And so this is what our function would look like. So as I travel right, as our function is going down towards negative infinity as x approaches positive infinity. And our function in behavior is approaching positive infinity as x approaches negative infinity. So that's what I'm going to write down. Oops. And again, I can't write infinity symbols, so I just use 2 circles.